Let's do a word problem, and this is a great word problem for solving the equation that we've been solving in this section. Suppose you inherit $30,000 at the age of 20. Is it possible to invest $25,000 and have over $500,000 for early retirement? Let's look at this next example. So this is one case where if you have some money at a young age, if you invest it, will you be able to have over $500,000 by the time you retire? So from age 20 to about I don't know, when you retire 50 or 60 or so on. Here it says the formula, what we looked at before for the accumulated interest formula, describe the accumulated value, and we've already talked about before. How long will it take $25,000 to grow to $500,000 at 9% annual interest compounded monthly? So here's our formula, and we want to take $25,000 as our principal. We want to accumulate and grow to $500,000. So you want to jump from $25,000 to $500,000. So you want to accumulate that much. So accumulation value would be $500,000. Principal, which is only $25,000. You have 1 plus, the rate can be 0.09, and it's going to compound it monthly, so that's 12, times 12, which is compound monthly, and we don't know what time, we don't know how long it's going to take for that $25,000 to grow to $500,000. So I'm just trying to solve for time, or t. Okay. Well, my exponential expression is right here. I need to get rid of this $25,000, so I'm going to go ahead and divide both sides by 25,000. So 500,000 divided by 25,000 is going to be 20. The 20 equals 1 plus 0.09 over 12, and that's raised to the 12t. So now I want to get rid of, or get this exponential expression. I want to undo it. So I'm going to take the log of both sides, or the natural log of both sides. In this case, I'm going to take the natural log because the base is not 10. The base is actually some ugly base right here. And what I'm going to do is I'm actually going to take the base and figure out what that is. So let's just do 1 plus 0.09 divided by 12. My base is actually going to be this. 1.0075 raised to the 12t. Now we take the natural log of both sides. The natural log of 20 equals the natural log of 1.0075 to the 12t. And what I can do is I can use the power rule, and I can take this to move out to the front. Okay, so I get natural log of 20 equals 12t natural log of 1.0075. Now, this is just a number right here. Whatever this is, it's just a number, and 12 just number. 12 times t times another number. If I divide both sides by that number, 12 natural log of 1.0075, then this will cancel out, and this will cancel out. These are all factors. So I would have natural log of 20 over 12 natural log of 1.0075 equals t. And I figure that out. The natural log of 20 equals that. My calculator divided by 12 natural log of 1.0075. And I get t is approximately t is approximately 33.4 years. So it would take about 33.4 years for $25,000 to grow to $500,000. So you would be a $500,000. You'd be $500,000 by the age of 53. If you're in my class, I talked about how when I was in in the summer and I made like $1,500 and I put it away, and that's many summers ago, how much money that grew in just maybe uh, gosh, 15 years. Well, 33 years and 40 years and 50 years, that money can grow exponentially quickly. So you can see that here, only $25,000. That's the price of a brand new car, maybe, right? In 33 years, you have $500,000 if you put that away and let the money work for itself. Okay, so I'm going to have you guys try it, and that's really cool. I think if you learn anything in this class, the power of how your money can work for you is kind of interesting. So on your own, to the nearest tenth of a year, how long would it take $1,000? So we're gonna go down to real life. I don't think a lot of us have $25,000 to invest right now, but let's say we just had $1,000, and we want to grow to $3,600. We want $1,000 to grow to about $3,600. That's a pretty nice chunk of change. If you have 8% annual interest, how much time would that take for it to grow to that amount? Okay, so go ahead and pause the video and try this one on your own. Okay, so for the on your own problem, I went ahead and put in the amount that I want to grow to, and the principal, how much I start off with, interest rate, and compounded quarterly. And I ended up getting this exponential equation right there. There's the natural log of both sides, and I solve for t, and t is approximately 16.2. So it would take about 16.2 years for $1,000 to grow to $3,600. So 16 years about to almost quadruple my money. Okay? Let's go to the next example. In this example we've seen before that the percentage of adult height attained by a boy who's X years old can be modeled by this function. And at what age, the nearest year, had the boy obtained 85% of his adult height? So now we're trying to figure out the age or the year in which the boy has 85% of his adult height. Okay? X represents the age from 5 to 15. So we don't know that age at all. So we're trying to figure that out. We know that he's obtained 85% of his height, so we're going to do 85. We want to know what age will he obtain 85%. So 85 equals 29 plus 48.8 log of x plus 1. So now we're going to go ahead and we're going to subtract 29 from both sides. We want to get this logarithmic expression alone, so we want to get rid of this 29 and separate by addition subtraction. So we're going to subtract 29 from both sides. My DOS is really, or my iPad is really slow. So let's go ahead and erase this, and it's not writing what I'm trying to write. So minus 29 minus 29. So 85 minus 29 is 56. 56 equals 48.8 log x plus 1. Now I'll get rid of the 48.8, so I'm going to divide both sides by 48.8. So I get, and I don't get a really nice number when I divide 56 divided by 48.8, so I'm going to leave this alone, because I get some really long decimal. So that's the exact answer right there. Now I have a logarithmic expression. So remember, we're going to translate to what it means. So the base here is 10. The base is 10. My exponent is going to be this, and it's going to equal this. So 10 to the 56 over 48.8 is going to equal the x plus 1. Subtract 1 from both sides. I get, that's what x is equal. So I'm going to type up my calculator. So 10 raised to the, and put in parentheses, 56 divided by 48.8. I get 14.1, or 14.04 minus 1, and I get 13.046 approximately. X. And now, as you know that I'm typing stuff in my calculator, please, watch this video, type these things in your calculator too, because when you take your exam and you're asking me how to type this in your calculator, I can't help you. If you're typing it in now and you don't get it right or you're not figuring it out, then you can email me, you can meet with me, you can go over it with me in class, but I cannot help you when you take your exam. So I hope that you're typing these problems in the calculator as I'm typing them right now as I'm making this video. So I get x is approximately 13.046, which is about 13 years. Oh. So, at approximately 13 years of age, a boy has attained 85% of his adult height. Okay. So on your own, I want you to go ahead and do the same thing, but this is a model for girls' height. So the formula is going to be a little different, but you're going to find the percentage, or find the age a girl is when she's reached 97% of her adult height. So almost her full adult height, 97%. Okay, so go ahead and pause the video and see if you can go ahead and solve this on your own. Okay, so I went ahead and put 97% in, and I solved for x, do the same way I did in the last example, and I end up getting 10 to the first equals x minus 4. When I add 4 to both sides, I get 14. And so according to this model, a girl has attained 97% of her adult height by the age of 14. That's pretty cool. So by the time a girl is 14, she's pretty much her full height at that point. Okay? It looks like it's the end of the section, so I'm going to go ahead and stop the video, and that's the end of chapter 4 for us. And so go ahead and if you have any questions, let me know. If you're in my class, we'll go ahead and do some work in class on this. And if you're in the online class, you can go ahead and start your homework. Please email me if you have any questions.